we see three factors. So therefore, we will have x plus 4, we will have x minus 1, and we will have x plus 2. And then the whole thing, which is x plus 4 times x minus 1 over x plus 2. The first row is always values of x. It's not a factor in the problem. It's the space where I put values of x. I need some room, like we do with all our tables. The first horizontal is values of x, first row. Okay. So now I need, how many numbers will you give me to put in that table? 3. So give them to me from left to right. Indeed, -4. Very good. -4, -2, and 1. Do we all agree with -4, 2, and 1?
Yeah.
-4, -2, and 1? Okay, very good. So for x plus 4, where would I put the 0? Good. For x minus 1? Very good. And for x plus 2? Good. Now I have to identify what happens in the whole with the whole thing.
So carry the 0 down for -4.
I do.
And then you would mark it out.
Undefined and -2. Very good.
And then a circle or 0.
Good.
Oh, a 0? What is undefined? 1.
We talked about that from chapter 1, if you remember, when we talked about rational functions, rational equations. The denominator cannot be 0. X plus 2 cannot be 0. Therefore, x cannot be -2.
No, I know that. I'm talking
Oh.
about why isn't one
Marked out.
yeah, marked out.
It's on
Because
top.
in the numerator.
It's
This expression cannot be undefined for any other number than -2.
Okay.
because if
If-
your numerator is 0, then your solution
The answer is 0.
There's
Yeah.
still an answer.
Okay. Thank
Very
you.
good. So all of these have positive slope. They are linear functions with a positive slope. What is the sign? Sequence of sign for any odd degree with a positive slope.
You're talking about the
All of them. All of them are odd degree with a positive slope. So from,
Negative and positive.
that's it. You can plug in numbers. You don't have to do this. But why would I plug in numbers since I study the end behavior of polynomial functions? I want to use what I learned. But it doesn't matter. Use the method you like. On the first subinterval, I'm multiplying or dividing 3 negatives.
So it's negative.
Absolutely. I'm multiplying or dividing 2 negatives. Perfect. 1 negative and no negatives.
Positive.
Perfect. So now this will tell me what to choose. This is the key. This tells us what to choose. What sign or which sign is less than or equal to 0? There's only one sign. We only have 2 signs. And only one of them is less than 0.
Would be negative infinity, then -4 with
So-
parentheses.
Yes.
With-
With a bracket for -4. Negative infinity, -4. It's okay because it's 0.
okay.
But union, parenthesis, -2, 1, comma, bracket.
And we're looking at negative because
I'm sorry?
we're looking at negative because the sign is less than.
Because only negative is less than 0.
Right. Okay.
Yes. If the inequality symbol would have been the other way, then
It would hit the
I would have used, yes, exactly, exactly.
And I have a question. If it
Yes,
was positive, how would we write the x into it?
I will write from -4 to -2 with parenthesis, bracket, parenthesis, union 1 to infinity, bracket, parenthesis. Let me write it. So for positive, x in the interval -4, -2, union 1 to infinity. Okay, which means we don't really have to do number 1 on this. Because that's number 1. Thank you, thank you. We can do it, but let's move on to other problems and then we can come back. If we have time, we can do that too. Priscilla, is this okay?
Yeah.
Okay, perfect. Now this problem we did it in class. We can do it again. This is copied from your text, and it's the same problem we discussed last time with the pH level in the mouth when we swallow something having sugar in it. It's the same problem. So let's browse through the entire thing and see what is more important to start with. So this is a polynomial function. Degree, what is the degree here? One more time, what is the degree here on problem 3?
Oh, I'm sorry.
That's okay, that's okay. I'm just browsing. I'm just browsing for a second. There is no degree on a rational function. There is a degree at the top and a degree at the bottom, but there is no degree overall.
Right.
Okay, so this is degree perfect. Okay, then the next problem is asking us to divide using synthetic division. The next one is what type of model or function?
Quadratic.
Excellent, and we have some question there. Problem 6, to find domain. Problem 7, to find some functions, no domain here, just some function composition. Problem 8, to decompose into inner and outer. Problem 9, to sketch the graph of a circle. Problem 10, to find the inverse and sketch both of them on the same coordinate. Problem 11, the distance. Problem 12, some extra credit to answer. And problem 13, to find the midpoint. Now you tell me what you would like to start with. Just wanted to browse through, so because I'm hoping we can do all of them, but maybe we should start with priorities. Let's prioritize. Yes, I'm ready, please. Yes, Danny? Number 3. Let's start with number 3. And number 3, we have f of x equals negative x to the 4th plus 25 x squared. So if you follow all the entire question, if you present everything in the table, then you will have everything, if you go line by line, word by word, then you'll see everything is in there. I mentioned everything for you, so you don't forget anything. So let's get the table started. What is the domain of this function?
Oh, real.
Yes, because it's a polynomial function, so negative infinity to infinity. Can anyone give us the end behavior after you give us the degree and the max possible number of terms? The degree is 4. The maximum possible number of turns then is?
3.
Very good. It doesn't have to turn 3 times, but it cannot turn more. Good. So that means that since the degree is 4, how many x-intercepts or zeros? So either x-intercepts or zeros. Same thing. 4 indeed. 4 x-intercepts. Even if some of them may be the same, we don't care. Good. Can anyone give us the end behavior? Even degree and leading coefficient is negative.
Are we going like in order?
No, we just want to fill the table.
Okay.
So let me. It's a very good point. So we determine the domain. We determine the. We are looking at for the end behavior. We already discussed the maximum possible number of turns. We discussed the degree. So now we want to find the end behavior. What is the end behavior? Even degree, negative leading coefficient.
It's gonna go down.
Exactly. negative infinity, negative infinity. Is that clear to all? I'm sorry? So remember x squared? Even degree with a positive leading coefficient. That's all you need to remember. Even degree with a positive leading coefficient. Then even degree with a negative leading coefficient. That's all we need to remember.
So that would just be the end behavior.
The end behavior. So we have the end behavior done. Good. X-intercepts. How do we find the x-intercepts?
Put 0 as the y, or set it equal to 0.
Negative x to the fourth plus 25x squared equals 0. Very good. Perfect. Good. So what do you think I am going to do next?
Square root that, like square both sides. Or square root.
Multiply by both sides by -1. X to the fourth minus 25x squared equals 0. I'm expecting 4 solutions. I will factor out. I cannot divide by it, but I will factor out. Very good. So then I have x squared minus 25 equals 0. So now I have to completely factor, and I can x squared minus 25. How?
X plus 5, X
Excellent.
plus 5.
So now we have to present 4 solutions, which we knew from the very beginning. That's why we established that from the get-go.
0, 0,
Exactly. X equals 0 twice, which is multiplicity 2.
and 5 and -5.
5 and -5.
Respectively.
Multiplicity 1, multiplicity 1. So I put them in the table. -5, 0, and 5, 0, 0, 0. What do I write for -5, 0? Multiplicity 1,
Oh, yeah.
cross. What do I write for x equals 0?
It's even, right? So it's
It will be turning, yes, of course. And what do I write for 5, 0?
cross.
Yes. Multiplicity 1 is always a cross, and
The negatives would turn around, right?
it all depends on the multiplicity. I
Well,
don't
that's
care.
what I'm asking, like with odd numbers of the multiplicity.
Yes, for odd multiplicity, it crosses, always. Yes,
How do you know what multiplicity is?
right here, it appears twice, m equals 2.
So because there's 2 zeros.
Correct.
It's 2.
2 zeros of 0, yes. 1 0 of 5 and 1 0 of -5.
And the more zeros that have the longer it crosses.
For
right?
odd,
Just for odd.
only for odd. Only the odd multiplicity is a cross. The even multiplicity
is a turn.
is always a term. Yes, only the odd multiplicity is a cross. But it depends how. If it's 1 solution, it crosses straight. If it's 3 solutions, it crosses slowly. If it's 5 solutions, even slower. Any questions? Okay, so now we want the y-intercept. Excellent. Since I already have it, I plugged in 0. Done. 0, 0. Final step, symmetry.
That'll always be like that, right?
Meaning
The y.
not 0, 0 always. This it cannot
Right,
always
not,
be
not always visible, but the y-intercept will always be.
when x is 0.
Okay.
Yes, y-intercept is always determined when x is 0. Yes. In other words, I have to find f of 0, always. And the last item is symmetry, and we're done. So let's see if we checked everything. We have x and y intercepts, yes. We have multiplicities, yes. And their meaning, yes, cross or turn. We have the end behavior, yes. Max min is that with the calculator, I cannot determine it. And I have the symmetry right now. Everything is done. We can graph it. So I have to find what when I study symmetry?
You have to look at when you put a negative x in there.
Very
it
good.
comes out
Right. So,
the same or the negative of it.
correct. This will not change. This will not change. Is the same function, which means an even function, which means symmetric with respect to the y-axis. Is that clear? You want me to go back? Is that clear?
Can you explain the end behavior one more time?
Yes, it's a even degree with a negative leading coefficient.
Is it negative degree with the negative coefficient?
Negative leading coefficient. Even degree with a negative leading coefficient. Right? Just remember x squared. This is x squared. This is negative x squared. Even degree with a negative leading coefficient. Yes.
May I have a packet?
Oh, yes, of course. So this is just an example of what happened last time.
Thank you.
So one more time, it is in your notes, but let's write it one more time. Odd degree looks like this with a positive leading coefficient, looks like this with a negative leading coefficient. Even degree looks like this with a positive leading coefficient, looks like this with a negative leading coefficient. I don't want you to memorize it. I want you to think in terms of the linear function or quadratic function, because this will go away in 5 minutes. But if you think in terms of the linear function, positive slope, any odd degree with a positive leading coefficient will have the same behavior, like the linear function with a positive slope. Even degree with a positive leading coefficient. It must look like x squared. Even degree with an, yes?
So the end behavior, like the answer that we write will either be an odd degree or an even degree?
No. The answer is negative infinity to positive infinity if it's a odd degree with a positive leading coefficient. Positive infinity to negative infinity if it's odd degree with a negative leading coefficient. Positive infinity back to positive infinity if it's an even degree with a positive leading coefficient.
So for this one, it's negative infinity to negative infinity, right?
Right, because it's an even degree with a negative leading coefficient.
Okay.
Excellent.
Can you explain the axiom of symmetry? Like how we got why we said it?
What did we say? Say it again.
Like how you determine that the symmetry was
Okay. So in chapter 2, so you know where it's coming from, we proved that f of negative x equals f of x, the function is even, and it looks like this as an example. We use this example to prove that. So this is from chapter 2. And if it's f of negative x equals negative f of x, we proved with this function. Symmetry with respect to the origin. So this is odd. So in this situation, if you replace x by negative x, nothing will happen. So let's do it one more time. F of negative x equals negative x to the 4th plus 25 negative x squared. So when I study symmetry, I have to replace x by negative x. Nothing happens here because it's the same. Negative x to the 4th will be x to the 4th. With minus in front is negative x to the 4th. Negative x squared is x squared with multiplied by 25. It's 25x squared. Since the function does not change, it must be even because this is identical with the original function. And this is the property that we studied using x squared. And we said every time I show that f of negative x equals f of x, the function must be symmetric, its graph must be symmetric with respect to the y-axis. Yes, please, Tiffany.
So without
working it out, I mean, because it seems like we just looked at it and that's how we came up. So without working it out, pretty much it means like if your powers are even, then would it be an even? You know what I mean? Because like I guess if the powers are even, then no matter if it's negative or positive, it would be the same answer. Could you
So
work it
if
that way?
yes, you could. However, I recommend be careful because you really have to check thoroughly that all of them are even.
Oh.
Yes. Yes. So I would have to agree with that. If you have a combo, however, it's not going to be the same. So if you have an x squared and an x cubed, it's not going to be the same. It's not going to be symmetric. Yeah. If you have all odd,
Then you can assume that it would be on.
yes, you could, but you still have to show.
Okay.
But I would have to agree
Okay.
with that observation, yes. Any questions? Okay, so are we ready to graph this function? Okay, so let's graph it. We only care about the chart. The only thing that doesn't fit in the chart is just the symmetry. Everything else is there. So we will plot.
Why did it say odd up there?
I made myself a note that the function is an odd.
Okay.
No reason. No reason. No reason to say odd. Absolutely no reason. 1, 2, 3, 4, 5. My apologies. So negative 5, 0, 0, 0, and 5, 0. Okay, so let's read the chart. It's coming from negative infinity and it crosses at negative 5, 0. Okay. It has to have a turn because it has to come back and turn again at the origin according to our findings. So the rest I don't care because I know the function is even. So it has to be the same. So this is f of x, negative x to the fourth plus 25x squared. The only thing I cannot determine is this maximum. So I need the graphing calculator. I need the graphing calculator for that. And it's going to be the same maximum on both sides. I know the function is even, not odd. Sorry about that. So in y equals negative x to the fourth plus 25x squared. And let's use standard viewing window. And I already have a cheat sheet here for me for the software. If I use standard, I will not be able to determine the max and on both sides. What is this? I have a glitch in the system. Look at this. 3.
Weird.
Yeah. Okay, let's try again. We know the graph. I don't think it's gonna help me. I don't know. We'll see. Okay. So everything we see here, we knew. We knew negative 5, 0. We knew that it has a turn at 0, 0. We knew it crosses at 5, 0. But obviously, I have to go way up. And I don't really care for too much below the x-axis. So go back to window. X minimum, I'm going to say negative 7 to positive 7. That's good enough. Scale of 1 is fine. Y minimum, negative 5 is more than enough. But Y maximum, I have no idea. I'm going to put, I don't know, it shows like, I don't know, 500. I have no idea. With a scale of 100. Let's see what happens. Ah, good enough. I'm only interested in determining the maximum. I know it's somewhere between negative 5 and 0. Second and calc, I want the maximum, which is 4, between negative 5 and 0, and enter. So the maximum is at negative 3.54, negative 3.54. And what is the maximum value? 156.25. Can anyone give us the other max without calculations?
It's Y, right?
No, I want this point. I have this point.
I forgot what, oh, so it would be positive 3.54, comma, 156.25.
Of course, because the function is even. Very good. So that's how we use the fact that the function is symmetric. Not all functions are symmetric. Yes?
How do we know, so if we're using a calculator to like, to look at our graph, how do we know how to like change the window?
Oh, I did. Click on window. Do you have your calculator?
Yeah.
Okay, click on window and just make the adjustments like I did. -7, 7, and 1. And I put -5. And there was no need for 500, it's too high. Let's put in 300. As long as I can read the maximum, I don't care if it's 500 or 300. So I had -5 to 300 with a scale of 100. Or you can put 50. Is that better?
Yeah.
Good. Anything else on problem 3? Yes.
So the maximum will be the 156 and the minimum will be 0?
No, the minimum is 0, 0. The local minimum. Yes. Very good question. The local minimum is 0, 0. And there are 2 local max. One at -3.54 and the other one at 3.54, and both of them, of course, are 156.25. Very good question. Thank you. Good. So let's look through and find the next problem. Yes? Number? 2. Very good. Yeah, we did it last time. Okay, find a PL problem in 30 minutes. What will you do? Right, so let's find f of 30. And we can put in the calculator in a minute. Graph the function. We graph the function with a graphing calculator, and the window, I gave you the window. Okay, but also I also said you don't need to copy. Just find after how many minutes is the pH level the lowest. So I didn't ask you to really graph it. Find the horizontal asymptote. So we're going to plug this in a moment. And then in part B, we want to find the minimum after we graph it. In part C, can anyone give us the horizontal asymptote?
Wait, which number are you now? Is
2.
2?
2. Number 2.
Okay.
That's okay. Number 2. We're going to find f of 30 in a minute. We're going to look at the graph in part B, but let's finish part C. Can anyone give us the horizontal asymptote? I know you have a meaning.
Yes.
Say it again. What type of rational function is it? If it's type 2, then I would say 0. But if it's not type 2, I cannot accept 0. That's okay.
This type 1, right?
It is type 1. Awesome. So which means it's the leading coefficient over the leading coefficient. What is the leading coefficient of the top? Excellent. What is the leading coefficient of the bottom? So then, what is y equals what? Excellent. This is the horizontal asymptote. Awesome. Part D, explain what happens to the pH level, blah, blah, blah. So now, let's graph the function. Let's put in the graphing calculator, and let's answer part A, and then also answer part D. So in y equals, don't forget, for rational functions, you must put parentheses around the top. 6.5 x to the second power, bless you, minus 43.4 x and plus 932. Close the parentheses, divide by, in parentheses, x squared plus 144. If you want, close the parenthesis, and if you want to see the horizontal asymptote, you have to make room for another function, which is 6.5. Now, the viewing window is given to us. It's right there in part B. So let's go to window and put 0, 60, 12, 0, enter, 60, enter, and 12. And now put 0, 8, 2. 0, enter, 8, enter, 2, enter.
Oh, sorry, 1 second. Window.
And then when you're ready, click on graph.
Can you show the window one time? I missed it.
It's on part B. It's written in part B. I messed up something.
Yeah, I think you put the equation there wrong. In the second part of the denominator.
Should there be outer
X
parentheses?
squared plus 1/4.
How did I put that in?
You said it out loud, right?
I said x squared and I wrote 4.
Yeah.
Wonderful. Okay. Okay, plus 144. Okay, let's try again. Let's see if not. Okay, that's better. And now the horizontal asymptote. So it's asking us in part, let's also go to second and table and plug in 30. So we can answer part A. So it's 5.249. 5.249.
So how will you do part A? So you just, when you find the graph, I mean, when you view the graph of B.
I went with a table, second and table, and I plugged in 30.
Oh, that's all you gotta do.
And I got 5.249. I didn't want to do it by hand.
Right, so that's all you have to do for that.
Yes, for part A.
Oh, okay.
Very good. So now we're asked to find the minimum. So second and calc, we want to find the minimum, which is number 3. I see from the graph that the minimum is somewhere between 0, this is 8, right, to 4. So I'm going to say between 0 and 4. So 0, enter, 4, enter. No, I want second and calc. I want the minimum between 0 and enter, 4, enter, and give me the minimum. Something is wrong here. Second and calc. I want the minimum. Left bound, 0, enter, 4, enter. Oh, so 4. I thought I had 0. Oh, no, I was thinking of the y-axis. I'm sorry.
Like 15 is a better number.
Oh, I just dragged it. Okay, minimum. Okay, left bound 0, right bound, yes, that's good. Did you get it from me? Because the software is not cooperating, or I'm not cooperating, one or the other. Okay, I'm just going to drag it.
But you said left down 0.
I'm dragging it.
11.90.
Okay, so the minimum is 11.9, so 11.9 minutes. So 11.9 minutes creates a minimum of 4.677 pH level. So minimum is when
What is that? 5.249.
so 11.9 minutes after we swallow something with sugar, then the pH level drops to 4.677. That's the pH level. So now we want to go back and just explain part D. He's asking us to explain what happens. So here's what happens, right? We the pH level in the mouth is normal at 6.5. I take a piece of sugar. 11 minutes later, the pH level drops to 11.9. And then obviously it starts leveling off. Back to slowly but surely, 60 minutes later, it gets closer and closer to the normal pH level, which is 6.5. That was the explanation on part D.
Now for C, it said what is the normal pH? So since
We
it's
already determined the horizontal asymptote in C. Yeah, right here.
right,
we
but
already-
she did a minimum and a maximum. But you just determined-
This was the
I mean,
minimum.
you said a minimum, so that's for B.
Yes.
Okay.
Yes.
So the X is what answers question B, and the Y is what answers question D.
So
So X would be after 11 minutes, and then
what is the normal pH level? That's the horizontal asymptote. Explain what happens is the explanation. Graph the function and find after how many minutes is the pH level the lowest. The pH level is the lowest after 11.9 minutes.
and then between 0 and 60 minutes, the pH level is at 4.67, or no?
So between 0, you mean part D?
Yeah, or D.
In part D, I have to say that at time 0, the pH level is 6.5. 11.9 minutes later drops to 4.677. And after that, it gets closer and closer back to normal.
Okay, so you have to write all that out.
Yes, yes, I have to explain that because I'm not asking you to put the graph in there. So you have to put it in writing.
Okay.
Yes. Does it make sense? Very good question. Thank you. Anything else that you would like to continue with?
I mean,
Yes?
when you did B and you were entering it on your calculator, I got lost. I wasn't sure how to do it.
To determine the minimum?
Yeah.
The minimum, we have to notify this. It's clear that the minimum is here, right? Okay.
Yeah.
So
how many minutes? Would be like the 11 minutes?
11.9 minutes later, the pH level drops to 4.677. So you go to second and calc. You're asked to find the minimum, press 3. We've done that. Okay, so now it's asking you for the left bound, and I put 0 as the left bound. And this is another way of determining the right bound. Just drag it with the right arrow. I drag it till it passes the minimum. I drag it with the right arrow, more right arrow, more. Make sure it passes the minimum. Did it pass the minimum? Now I can press enter, and this will be my right bound. And then I press enter again, it will give me the minimum.
How do you get that number?
I'm sorry?
How do you get that number? We don't want to just push.
Because I know this, I see that this is the minimum value. There is no other lower value than this one. So as long as I pass it, I can create the right bound.
So for the right bound.
So hold on, 1 second. So is that clear?
So basically you're saying you gotta stay at your lowest, basically, as you're going forward.
So when I look at this function, let's follow my hand. Right. Is this a minimum value? Is this higher than the minimum value?
Yes.
Okay, so I choose the left bound 0, and then I drag the mouse till it passes the minimum anywhere I want.
Oh, anyway you want. Okay.
Anywhere, it doesn't matter what, here.
Okay.
I give the calculators the right bound here, and it will give me the minimum.
Okay, you got to enter again though.
Exactly. As long as I pass the minimum, anywhere, as far or as close as I want to. Yes.
After you passed the minimum, did you press enter once or twice?
Once for the right bound, and the second time because I don't want to guess. It's asking me for a guess at all times. Why? I have no clue. Maybe because you may be looking at two different minima, and it's by you entering the guess, the calculator knows which one of those two you want, something like that. Is that better now? Everyone, any questions? Is this okay? Other questions on this problem? Yes.
is that
Yes?
general? So you said that you should put parentheses around,
When you enter in the graphing calculator a rational function, you have no choice. If you don't put parentheses, for example, x plus 1 over x plus 2. If you don't put parentheses around top and bottom, the calculator will say x plus 1 over x and then outside plus 2. It will do something totally different.
Yeah,
Then
because I
what-
forgot to put the parentheses around
Right.
the denominator and it didn't give me the lower bound.
Right.
But
Right. So always in rational functions or rational expressions that you want to determine, you have to have parentheses around the top, parentheses around the bottom. Very good question. Okay, anything else from here? What else would you like to continue with?
We do 4.